Awesome. Hi, my name is Xavier. I'm here to present to you this hobby project that I've been working on. It's called PAW. It's an exploration of bidirectional programming in the context of music production. I think you're all somewhat familiar with bidirectional programming, but maybe not with music production. So before I introduce the project itself, I'll give you a little bit of a primer. So these days, oh, this is not working. Well, I guess I'll just do this. So these days, music production on the computer is typically done with software called DAWs, which are digital audio workstation. And they're originally based on like old mixing consoles and drum machines. And they provide you with various kinds of domain-specific UIs that are practical for arranging and producing music. I'll just show a few of them, but the most common one, I would say, is the track editor that you can see here, which shows a stack of different tracks. Each track corresponds to an instrument. And then those tracks can have little clips of audio or MIDI data. MIDI is just a representation of a sheet music that can be played by a virtual instrument. And then as a musician, I can arrange those to arrange my song however I want. DAWs also come with mixers that I use to combine different tracks together into the actual audio output that I want. This is also where I can apply effects to my track, which can shape the sound in one way or another. So for example, add in an echo, distortion, improving the quality of the audio. And then this is, again, a different type of domain-specific UI, which is a sequencer, which I can use to have a higher level view of an audio project and arrange bits of audio, maybe if I'm working on a song in terms of verse and chorus. A different tradition of live coding, music making on the computer is live coding. It's here I've got a little demo that I found on YouTube. And basically, in live coding, the artist is writing a program as it's being executed. And this program, in this context, produces audio. Performance is editing the program live. This is often done in graphical audio. Thank you. This is usually done for generative art, music that we use, mostly for electronic music, because this is what programming is best at. If you want to do things that are more traditional, DAWs are actually better. You get those UIs that make a lot of those things easier. If I'm working on a pop song, I want to cut the audio very precisely, arrange, maybe I'll have 7 takes of things vocals, and then I'll cut them very sharp and select only the best ones for each sound in the audio. This is the sort of stuff that I cannot do in the live. On the other hand, being able to write a program for this can give you a lot of power that you just cannot do with a DAW. And so this is this is where my project is trying to carve a space for itself. So PAW, which stands for programmable DAW, it's a combination of live coding with some of those domain-specific UIs that come from traditional DAWs, and the two are connected together via bidirectional programming. So it's rooted in live coding. I'm just editing a program live to produce audio, but I have special syntax inside of the domain-specific language that will generate widgets inside of a GUI, which allow me to edit the code. And those widgets this editing is bidirectional, so I will edit the code, which changes the GUI, and I will use the GUI to update literals in the code and also get direct feedback in terms of the audio, which we'll hopefully be able to see right now in a demo. So I have a video in case if it doesn't work, but this is what it looks like. That's going to be a little bit tough for me because I'll have to look there, but we'll make it work. So maybe I'll just quit this first. This is basically what it looks like if I don't have any project open, and then here on the side I just have a basic normal, like a terminal, and I open a project file, a code file in a normal text editor, which automatically connects with PAW, which is on the left here. PAW is a language server, implementation of a language server for this DSL that I have here. And so this is how the two communicate. And so let's maybe hear some music. And this is bad news for me. This worked earlier, so tough luck. Yeah. Well, this is not working, but I guess this is what I have the video for. So let's go. Oops. Anyway, so here in the video, I'm demonstrating starting the audio. Oh. Yeah, maybe it just wasn't loud enough here. Yeah, perfect. Awesome. Yeah. So basically, this is the little tune that I wrote for this demo. But you can see those different domain-specific GUIs, widgets that appear here. They're generated from this code. So for example, here I have this track that looks like one of those track editors that I showed earlier. And this is generated from this little track here that I have. I have two little clips here, one there and one there, and they correspond to those two lines. And so I also have these little sliders here. Maybe I can show an example. So this is a guitar. This is the slider to control the level of the guitar sound, and so I can adjust it here. I can turn it back down. If I release this thing, it'll update the value here. But I can also, oops. What am I doing? Yeah, this is really hard to use. Okay, anyway. And I think I'm muted. Yeah. Anyway, so this is kind of the bidirectional aspect. I have maybe some other things that might be interesting. I have these little checkboxes here. They're just basically a wrapper around a Boolean. I have an example here. If I check one of these checkboxes, maybe the click track here, it'll turn the Boolean into a truth value. There you go. This is what I use to record those little tracks, to give me the rhythm. Anyway, maybe a little bit more interesting are those tracks up there. Here I have the drum track, and those track editors are very, very simple. Like the only operations that I can do is moving those clips around and resizing them. In a typical audio, you'll have way, way more features. I'll pause this because now it sounds bad. You'll have a lot more features. You'll be able to import like clips onto those tracks. You might be able to duplicate them and so on. Those features are all missing from this. I only have those basic functionalities. It's not actually a problem because since I have this like human understandable representation of my data here, I can basically, duplicate this. I make a copy, and then now I have another clip. And if I want to, use a different clip, I can edit this. This is the advantage of having this representation. And of course, this is a text editor, so if I want to undo all the changes that I just did, I can do this, and everything's back to normal and should sound better again. Another great thing about having this programming language representation is, again, this UI is super limited. It really does very few things. And for example, you've noticed maybe that if I put the playhead there and start playing, we can hear some music. This is because I'm looping those tracks. In a traditional DAW, I'd have a specific UI that allows me to do this. I don't have this here, but it's a programming language, so I just wrote a loop function here, and then I'm pulling it in several different places. Again, it's a LSP, so I have this show usage, and then I'm just using using this when I'm sampling a track to say, hey, I want to loop this section, and then it just does. So it might be nice to have a UI for this, but I don't need it in order to be able to do this in the system. So yeah, that's basically all I wanted to show in this demo. Moving on. Yeah, so just a little like presentation of like how the syntax works. I have the syntax, basically it's extremely simple. It just wraps around the literal and makes it interactive. So here, this slider syntax wraps around -6 here, and then I have the bounds of the slider. In terms of the semantics of the language, it's as if the like syntax for interactive widgets just wasn't there. It's discarded at compile time. So I could just remove this slider and it would remain the same. I often do this when I'm like tweaking some stuff. I create a slider, and then once I have a value that I like and I don't actually need the slider anymore, I just remove it from the code. The syntax is type aware. So here, for example, I have this union type that can take several different values, and so if I add a drop-down widget for it, it'll allow me to select among the different possible values for that type. And then I have those domain-specific UI. I mean, those, I have only the one for now, but I think in the future it would be valuable to have more. I would love to have a sequencer at some point. Of course, all of this is not really new. I'm merely like applying existing concepts to this specific domain. One of my first and main inspirations for this work is Sketch in Sketch. A lot of you probably know about it. It's a direct manipulation programming system for creating SVG documents. And so as a user, I would write code on the left-hand side, and it would generate this graphic on the right-hand side. And this graphic comes with a bunch of those little signifiers of the kind that I would find in a, in a traditional SVG drawing application. And if I use these signifiers to update the graphic, it'll compute a program transformation and update the code on the left. The program synthesis that it uses is like very powerful. And so it'll like essentially run the code in reverse to figure out exactly what needs to change in order to make the code still produce the same graphic. Another work that uses program synthesis, in this case in the context of music, is this work by Santa Lucido, Human-in-the-Loop Program Synthesis for live coding, which shows you this grid, this drum grid on the right-hand side, where you can input a specific rhythm by tapping on those circles, and it'll generate code on the left that will produce this rhythm when played. But then you can also edit the code. It'll update the pattern here, and then you can edit back the pattern, change the code, bidirectional programming with program synthesis. In comparison to these two works, PAW is actually tremendously simpler. Its interaction model is just, I say this thing is interactive in this way, and that's it. There's no program synthesis. It makes it less powerful. I think program synthesis might bring some interesting things to PAW, but I also like the simplicity of this system where I really understand very clearly what the GUI is going to do when I interact with it. My experience of interacting, especially with Sketch in Sketch, is that sometimes it can be a little bit difficult to make sense of all the signifiers that are displayed for a specific program, and also to understand what the program synthesis is going to do when I'm going to change something. PAW is actually a lot closer to this work called Livelets, which is an extension for the Hazel programming language that adds those syntactic elements, like here, for example. So those syntactic elements introduce those widgets that are baked into the editor, unlike PAW, where you have this window of GUI on the other side. And interacting with those will result in like direct change in the output of the program. So those actually, those interactive values, those livelets, produce closures that are reevaluated when I change the GUI. They also like perform macro expansion to obtain the actual value that is going to be used in the program. In this way, again, PAW is a lot simpler. There's no macro expansion. I just like wrap a literal value that is baked in the code. Something that I like about this is that I actually know what the value is, and I can, as I said, remove the interactive syntax, and the program remains semantically identical. A great advantage of livelets is, the GUI is embedded in the text editor, and also for very complex GUIs, like maybe this table here, if I had to have the code representation of this, it might be a bit verbose. And then another work that I really liked in this context is Anderson's visual syntax for the Racket programming language. So those are, if you know Racket, you have those powerful scheme macros in it. Those are basically visual equivalent of those macros. Here's a great example that shows a function, a balance function for a red-black tree. If you've had computer science classes, you probably heard about this. And it can be a little bit difficult to get a good intuition of those things when they're, just like data structure written in code. But when you have those visuals, it makes everything a lot more intuitive. So yeah. The last time I presented PAW to somebody who had never heard about it, they asked me this. They were like, "This is cool, but like, what's even the point? Like, what are you trying to make? Are you trying to make a better environment for live coding?" And in part, but I'm not a live coder myself. I make more traditional music, and so I'm not really trying to make a better live coding environment. I'm actually going after DAWs themselves. As an amateur music writer, I've used DAWs for several years, and I have like little frustrations with them. And mainly my frustration is that they're, I'm a programmer, and so I feel like they're not enough like a programming language. They don't have enough of the programming language features that I really like. What I mean by that is that GUIs, they're powerful, but they're restrictive because they lack compositionality, whereas code is open-ended, because of its highly compositional component, but code is non-visual. And so the impact of lack of compositionality of GUIs is that most of the features in a GUI are ad hoc. If I have a UI to do a specific thing, it was baked into the GUI by the developer. Whereas in a programming language, most of the features are just emergent from recombination of other things. A big impact of this is that the complexity of a GUI will grow along with the number of features that I have in my application. And what I mean by that is the dev work to implement is going to grow, the maintenance work will grow with the number of features, documentation becomes more complex, discoverability can become an issue. In a programming language, some of these things are don't apply in the same way. You have a really high cost in learning to program and in learning a specific programming environment up front, but once you have this cost, programming language gives you, a programming language can give you the tools to manage complexity and organize things a lot better because of compositionality. But in a GUI, as I said, you get this power from having those visual elements making some tasks way easier than in a programming language, which is why bidirectional programming can be a great tool to try and bridge this gap between the two. I have a couple examples. I think the second one is probably more interesting given the time. For example, in a DAW, I will often want to save part of a project to be reused in another one. A typical example is maybe I set the settings for an effect. I really like an echo that I set up, and I want to reuse it on a different track or in a different project that I made. And so I will want to save this preset. For this, I need to use a specific GUI that was baked into the DAW. It's a different GUI for saving different things, and I need to know exactly where it is, and it has really low abstraction power. I just save something, and then I import it exactly as it is. In PAW, because it's a programming language, I can just declare a function and use it. It's a generic programming concept. It works for anything in the same way, and it has higher abstraction power because I can use function parameters to parameterize and create custom effects and whatnot. I'll conclude by saying why not use PAW, which is that right now it's not great. It's a very early prototype. The DSL is not really great. You probably saw that it was very messy. If you're used to live coding, it's not the best programming language for that. And then I talk about issues of discoverability in a GUI, but this can also apply to a programming language. The widgets are outside of the code, which can make it difficult to understand which slider is affecting what, and it's missing a lot of DAW features. So I'm trying to see if those problems can actually be solved, or if they're like intrinsic to the domain. Then have future plans, improve the program, fix bugs, and then I want to get other people to give me feedback to actually use the program, make some music, and then have a lot of long-term ideas. But I think that's the end of my time. So. Yeah.
You're supposed to go through Discord or?
Yeah.
No, let's do live questions. Well, we can also do the Discord.
So this is very nice. So,
wait, hold on, microphone's on.
Oh, yeah.
Thank you. That was very nice.
Thanks.
So I was interested how you started to use functional abstraction to go beyond what a physical, emulation of a physical mixing board could do. I imagine that when you're composing music, you want to explore various variations, and you want to save something you tried and go back and do something else and mix them up again. And rather than functional abstraction, that sounds to me a lot more like version control.
Yeah, absolutely.
But on the other hand, Git sounds to me like the worst UI for trying to do it with.
Yeah.
Have you thought about this?
So not really yet, but I am using Git to version control my tracks that I make with PAW. I do think being able to track changes in this way is extremely valuable. For now, I haven't really thought of a solution for this. I'd be very interested to figure one out at some point or read about it.
I have a different angle of question. It seems like the way you talk about the problem and what we see in the code, you have a ton of value and benefit from making the mechanisms of your track transparent, right? Like the data of your program becomes transparent, but the sort of programmatic part it seems less valuable. Like you could just put loop equals true on the end of a track rather than having to write a function for it. This is not meant to be a criticism of being programmable, but it kind of seems like actually probably the biggest advantage you have over a traditional DAW is just transparency of the data and the ability to copy and paste and make references and move things around.
Yeah.
Is that something you've given a lot of thought to? Do you think there's more opportunity there?
Yeah, actually, I think it was a main element of designing this project. It's like thinking about how to translate traditional DAW features into this context. A lot of it was thinking about how do I select like the smallest amount of features from this GUI so that I can use this in this environment. Because basically I'm trying to design those like GUIs to be as compositional and as restricted as possible to be able to keep leveraging the power of manipulating the source code directly and writing programs. I don't know if that answers the question.
I think so, yeah.
Who should go next? I'll go.
Yeah, excellent work. It's really great. Real quick question though. I was wondering, is it possible that any of the existing DAW products have an API or an SDK such that you could like progressively augment their user interfaces with programmability or a two-way mapping between a code representation and while also maintaining the power of like some of the DAWs are really, really nice to use for most things, but for some things they suck. And I wonder if you could like layer your stuff on top of an existing DAW.
I don't think so. Like DAWs are extensible to some extent because you can write your own plugins for effects as shared libraries, but I don't know of any DAW that will allow me to actually extend it in this way. Usually extension mechanisms are really restricted. It might be interesting actually to try and fork an existing DAW to add those features to it. But as like mentioned earlier, I had to think very thoroughly about the representation of data and how those the GUI actually manipulates the bits of data in the code for it to work properly. So I think it would be a major overhaul of an existing DAW to be able to do that.
Really nice work. I'm curious, you said your system's simpler than Sketch and Sketch. It doesn't do program synthesis. Do you have any examples of where that is a limitation? Like, are there times you do a change in the UI and your system doesn't update the code the way that you would ideally like to?
Well, I mean, no. That's kind of the thing that I mean is that the. Oh, do you mean the fact that I don't have program synthesis in PAW? Where is that a limitation?
Yeah, like
Okay,
are there
so-
examples where that
Oh.
doesn't update the code the way you would want it to? Or not, maybe, I don't know.
Yeah, I don't have a good example of this right now. I think it's more that I will give you a more general answer, which is that writing programming, like writing code with PAW like this requires to deal with a lot of boilerplate. And I think a lot of it can I can get rid of a lot of it by improving the programming language, but also a lot of it is kind of inherent to just having to type code. If I had a GUI that can be a little bit smarter, that can do program synthesis, I would be able to get rid of probably a lot more boilerplate by having the GUI generate some of the code that I'm writing.
Thank you.
Hi, that was really cool.
Thanks.
This is a programming conference, so I'm going to ask a non-programming question.
Awesome.
You've made a tool for art. Could you talk for just a tiny little bit around any artistic goals you have for this project? Like if there's a kind of music you want to make that you couldn't make with traditional live coding or DAWs or something like that this might enable you to do?
Yeah, I think basically for me, what I find exciting about this project, and it's something that I've already had the chance to explore by using it, is that it gives me a direct connection with the tool that I use to make music. When I was working with traditional DAWs, or when I still work with traditional DAWs, I have several layers of abstraction between what the developer of the DAW or of the plugin wrote and what I'm actually using, which means that I'm only limited to what this is enabling me. Whereas here, in the context of making this project, I've had the chance to be like, oh, I'm using this ADSR envelope, but I wonder what happens if I tweak this little bit of the code, and so I don't know, fork my own ADSR library that I wrote, change some bits, and then, oh, this is producing something different and interesting. Maybe it's, yeah. This is, I think, one of the big values for me. I'm still interested in making traditional music of the type that I was making before, but this is definitely enabling me to think a lot more outside the box and experiment a lot more, which I like.
Very cool. Thank you.
Thank you.
I think it was so sorry.
Hi, I'm going to make a programming question then. So the other side, the side of programming, what are your thoughts in terms of have you explored the space of mutability? How do you handle time? Because you're kind of handling a continuous thing, streams and stuff like that. Have you ever felt that it will be cool to have a particular syntax or semantics that are not normal or useful for common programming, but would be for live music production?
Actually, yes. So the way I wrote the DSL for this, and the way I designed it at first is I wanted it to be kind of general purpose, because my goal with this project is to retain as much programming power as I can while making it. I don't want to make too many compromises. But after making this and working on several different tracks with it, I've realized that this program is really not good. I mean, this programming language is really not good for making music compared to live coding programming languages. So I think there are trade-offs to be made here in terms of improving the language that will change the way it handles some of those things. Is that a good answer? Yeah, thank you.
So I'm curious if you've thought much about a multiplayer aspect to this, specifically if you think about how, in programming languages, Git is really good at diffing and forking and merging for asynchronous collaboration.
Yeah.
And if you add networking, then I could imagine really easy ways to introduce synchronous collaboration and jamming into the GUI or even into the code. And so I'm curious if you thought about those things and how this tool could enable better culture or ways of social experimenting around that.
I've thought about it a little bit, and I know of like DAWs that are geared towards collaboration. I think a problem that I see with this is that music is highly, like making music is highly dependent on latency. And network latency is way, way too high to make music comfortably. So I haven't really explored that area too much, but there might be interesting things to do with it. I'm not really sure. Okay, thank you very much.